Yeah, so let's say this one. In this question, what we have to do is that we have to print a hollow diamond pattern. Now, what is a hollow diamond pattern? A hollow diamond pattern looks something like this, which means that if we provide a number, let's say 4, then you can see that first row is just having a single star, and then you can see that pattern is moving something like this, that then 2 stars. Obviously every row other than the first one and the last one, it is going to have 2 stars, but it is increasing, which means that you can see the gap is increasing in a symmetric fashion, and the 4 counts for that. This is the first, this is the second, this is the third, this is the fourth, which means that the fourth row is the maximum width, and then again this is third row, this is second row. So you can understand that mm, so in this case we can understand that 4 plus 3 7 7 essentially 7 rows are there, the 4 being the fourth row being the widest row. Okay, so just to give you a few more patterns, so if it is, let's say, 6, then the pattern is going to be something like this. First, second, third, fourth, fifth, sixth is this one, the widest one, and then again it starts getting shrinking, and in the symmetric fashion it has to close down. Again, let's take a shorter example. So let's say only 3 is there, then you can clearly see that first, second, third one is the widest one, and then again it starts shrinking in the symmetric fashion. The whole idea is that this is a hollow diamond, which means that this diamond is not filled from inside, it is just filled from outside. Okay, so that is fine, that is fine. Now this is what we have to implement, right? uh, so we have already understood how the pattern is there. You just have to return a string which prints this on the screen. Okay, and there are not much restriction. The only restriction is that this n, the number which is provided, this is definitely greater than or equal to 2. Okay, so it is not 1 or 0 or something, right? You're told that it is greater than or equal to 2, so minimum it can be 2, and for 2 obviously the expected behavior is something like this, right? And then from 2 onwards any number can be given, any number can be given. So let's say even 13 can be given, 23 can be given, anything can be given, and then your diamond has to be like that. Okay, so yeah, so this is the question. Now let's see how do you implement this. So you can definitely pause the session and then implement it on your own and then see the solution. Yeah, so you can see that uh, what we are doing here is that so let's say this solution is being passed a number 5. So in order to implement this solution, what we are going to do is that uh, so firstly let's print this n just to prove that this is being called. So you can see that, yeah, whatever the number you are passing here, that thing is being passed here. So let's say you pass 4 or something, that is being passed here. Now we have to right now I'm just printing that number, but actually what is the expectation? The expectation is something like this. So let me firstly write that expectation. So obviously the outermost will be something like, so let's start from something like this. So something like 1 star will be there, then it will be something like this, and then there will be a repetition. Repetition means that something like this. So you can understand that we have to actually find the pattern. So how to create a pattern like this? Okay, so let's see a few visualizations what we are able to see. So you can see that if we consider this first, second, third, fourth, uh, then let's consider this as the zeroth row, this as the first row. There is a reason for this, we'll see. So if we are given n is equal to 4, then we will go to 0 to n minus 1, which means that we will go from 0 to 3. So 0 1 2 3. Let's see this. Now let's try to generalize that. Obviously in the first row you are having 1 star, that is fine. In the second row onwards you are having 2 stars each. So this will be 2 star, this will be also 2 star, everywhere a 2 star except in the first and the last one. Now let's see the number of gaps. You can see that here the number of gap is 1, here the number of gap is 1, and till here. So what is the additional thing, which 2 stars are the additional thing? So 1 plus 2 3. You can see that 1 2 3, 3 is the gap. Now what is the gap in this second row? Sorry, and the row next after, which is the third row, is essentially fourth row, but the index, the row index is 3, right? Because it is starting from 0. In that case you can see that earlier it was 3, but here it is 5. You can see that 1 2 3 4 5, and essentially because this gap was 3 and then 2 additional stars are there, so this whole gap is now 5. So what are we finding the pattern? The pattern we are finding that here 1 gap is there, here 2 gap is there, no, here 3 gap is there, and then 5 gap is there, right? And we will not bother about this, because again this is like symmetric. So if we are able to print this half diamond, then if we can simply reverse that, and then we will be able to get the rest of the diamond. So the main critical thing is this, printing this part. Okay, so 1 3 5 gaps are there. Now what about the first one or second one? What is happening is that, let's say a few stars are printed, that is fine, but how do we know that what is the gap? What is the gap before and what is the gap after? Okay, so so you can see that one simplistic thing we can understand is something like this, that this maximum width, you can understand, is that that maximum width is same across all, and you can understand that if this is what is the maximum width. So here you can see that 5 is the gap, and then 2 stars, so 7 is the maximum width, right? And then you can see here that here the internal gap is 3, and then 2 stars 5, which means that the maximum width is 7, but we are taking this, but this width is 5, which means that additional 2 width is like here and here. So one gap is here and one gap is here, right? Similarly you can see that 2 gap is here and 2 gap is here, 4, and then 2 6, and then 1 7. So you can see that in that fashion we can analyze that the whole width can be constant, and then that is just decreasing towards the top. But if we are starting a loop from, let's say, from the beginning, then we have to somehow find the calculation, do the calculation, so that this whole thing is able to be printed. This whole thing is able to be printed, right? Now let's see. Let's see. So let's start from a simple. So let's start with a normal for loop, and that I, obviously it should go till n minus 1. So let's while less than 1, but let's start this from 1 rather than 0. What we will do is that from 1 till 3, so from 1 till n minus 1, so n is 4 in this case right now. So from 1 till 3 we are printing, because all these rows involve 2 stars, right? The first one is special case where there is no 1 star, so can't we handle that on our own? So we'll handle that separately, and from 1 we are going to see here. Let's remove this, not needed. But what we are going to print, let me see. Okay, so firstly what we are going to do is that you have to see that maximum width. Maximum width is what? Can you see a formula for this thing? You can see that this formula is if this is 3, then this pattern is odd numbers. And the pattern for odd numbers is what? The pattern for odd numbers is 2n plus 1 or 2n minus 1, depending on what how the pattern is happening. So you can see that this is 3. So 3 into 2 is 6. 6 minus 1 is 5. So you can understand that here also this formula will work. 2 into 2 is 4, 4 minus 1 is 3. Here also 2 into 1 is 2, 2 minus 1 is 1. So you can understand that 1, 3, 5, this whole pattern will follow 2n minus 1, where n is that core number. So if n is this I is there, then this gap, internal gap, is 2i minus 1. You can understand. You can understand that if I take this 1 to 3 as I, which is here in this case, then the gap is I minus 1. That is fine. But what is the maximum width? The maximum width is 7 in this case. You can see this is the 7 gap, right? This internal was 5, and then 2 starts, that is 7. 7 is the maximum width. Now we have to calculate this 7 in terms of n. If n is 4, then 7 can be written as 2n minus 1, right? Then you can understand that what we can do is that so why that whole gap is important. Whole gap is important. Let me show you. So so firstly, you can understand that, let's say I don't have to print this second one. We'll print, let's say, only the first one. How to print this first star. So you can understand that this whole gap, whole width is 2n minus 1, because we just saw this 7 is 2 into n minus 1, where n is the provided number. In this case 4 was provided, so 4 into 2, 8 minus 1 is 7. That is fine. Now using this 2n minus 1, so if I am talking about n minus 1, so this 2n minus 1 can also be written as 2 into n minus 1 plus 1. You understand? So essentially this thing is equivalent to 2n minus 2 plus 1, which is same as 2n minus 1, right? But why I am writing in this pattern? Because now I have to have one star, then 2 into n minus 1, which means that left side and right side, both sides, the gap will be n minus 1. That gap is what we have to print it. And how we'll print that gap? We can print something like this, that let's say one gap is there and we are repeating this. So we know the repeat function is there, which means that it will repeat this string and concatenate in that manner. How many times we want it to be done? N minus 1 times. Then we will have one star, and then again we will repeat it n minus 1 times. So now you can understand that we will have a 2 into n minus 1 plus 1 times. So this whole width will be 2n minus 1. Okay. So if you simply let's comment everything, and if we simply run this, then obviously we will just get one. We will just get one star after some gap. That is fine. Now this is the main part. Now here, what is the pattern? So firstly let's write the pattern which is internal, and then we'll write about external things. Okay. So what is the internal pattern? So there is a star. You can see that there is a star, and then there is some gap. So is space dot repeat, what is the argument, will come back to it, plus, and there is another star. After star also there is some gap. Before first star also there is some gap. But firstly let's see what is the internal gap. Internal gap we saw, right? It is 2i minus 1. Okay. If I is there, then if it is 2 into I minus 1, then this is the gap. So you can see, but right now obviously it is skewed. Because we have not given proper gaps towards the left and towards the right. But how much gap we need to give towards the left and towards the right? We can see that if 2i minus 1 gap is the gap, internal gap, and then there are two stars, which means that 2i minus 1 plus 2, which means that 2i minus 1 plus 2, which means that 2i plus 1. This is the total width consumed by till star. And what is the total width we are maintaining? Total width we are maintaining is 2n minus 1, right? 2n minus 1. So isn't it the case that 2n minus 1 minus this 2i plus 1, let's take this, let's use this variable as t, and let's print this, that what is this t. Okay, so 2n will not work, 2 into n we have to write. Okay, so something is not working, so let's see, 2n minus 1 plus, okay, so 1, why I'm writing 1, I have to write t, sorry. So t, I'm trying to figure out that for each of the iteration what is t, and you can see that this is what we wanted, that for the maximum width, this t means the additional gap which is needed towards with left and right padding added, that thing is 0, right? Because that should be 0 because this is the maximum width, right? But there should be 2 gap combined towards left and right. The combined gap should be 2 for the just previous row, and which means that there should be 1 gap towards right and 1 gap towards left. And similarly this is 4, which means that 1 gap towards right, and 2 gaps towards right and 2 gaps towards left. And this is general. You can see that even if I do 5, then you can see that this thing is working perfectly, 0 to 4 6. So which means that now all we need to do is that take this value t, whatever I am printing t, and we have to add t minus 2, sorry, t by 2, that the padding of this. So I'm talking about this, so I need to add a padding towards right, and I need to repeat it for t by 2 times, right? And same t by 2 times here also. So obviously when this will be 0, then obviously that will be empty string. But let's say when it was 2, then 1 and 1 width will be added towards left and right. If it is 4, then 4 by 2 is 2 towards left and 2 towards right, that gap will be added. Now if you add that gap and now you print this, then you can see that this pattern you are getting, right, till maximum. You can see that when maximum is there, then there is no padding. And now you can see that we are getting into shape. Once half diamond is printed, then it is straightforward. You just repeat this one more time, and now I'm just so earlier I was going from 1 to n minus 1. Now I will go from n minus 1 to 1, n minus 1 to 1. 1 means greater than 0. This is I minus minus, right? And exactly the same thing will be repeated. Yeah, but you can see that now this thing is repeated twice, which means that rather than n minus 1, I should repeat from n minus 2. So this n minus 1 part, the last part, is just one time, right? So it should be not repeated. So now this is better. And again, the last one was a single star. Everything right now we are doing in for loop is for only one star. So let's add that single star. So now you can see that we are getting the pattern, right? And this pattern works for 3. You can see that this pattern works for 5, right? But right now you can see that undefined is returned. We have to return this whole pattern as a string of that maximum width, whatever we want, right? So what we are going to do, let me see, we are going to create a string out of it. So let's say my answer is some empty string, and then rather than console logging, just I will keep on concatenating that thing, right? Rather than I'll just keep on concatenating it, right? And let's do the same thing here, and let's do the same thing here. And again, this will not work. This will give you a gibberish thing, and then you have to return the answer, right? And this will give you a gibberish thing because we have not added properly this new lines, right? So obviously this first time the new line is not needed because yeah, it is empty string, just is starting the first line is fine. But from the second one onwards, you have to add a new line at the beginning. So /n. So let's add this. Let's add this everywhere, here and here. it's not needed. We could have written a slash and here also, but that is fine, that is fine. And now you get the pattern. So essentially what is happening, you can clearly see that now this is no more needed because all the analysis is done. You can see that this whole thing returns me a string which has all the pattern, and here I'm simply taking that and printing that. Okay, so I can see that 1 2 3 4 5, and then from 5 4 3 2 1. So this thing, and this, if it is 4, then you can see that 1 2 3 4 4 and then 3 2 1. Okay, so in that fashion it is working. So yeah, that should be fine. I have a few test cases also on that we can test. So let's take a few examples from our test suite. So this is the URL where test suite is there. This URL I'll give in the description of the video. So if I try to run this, then essentially this has for 2 4 and 6 this has the patterns which is expected, and let's say I run this, then I get successfully the answer. So just one thing regarding the test suite, that you can understand that the width, like after this the spaces are there, which means that the width is maintained. Okay, in case you are printing like till here only, not spaces, so then your answer will not match. But anyways, so that is the way in which the test suite is written. So if you want to see that, then you can correspondingly change that, then it will match. So you can see that there are no assertion errors, which means that everything is perfect. So that will be all for this video.